Welcome to CES, everybody. We're kind of winding down now on Thursday. Everybody had a great time so far? Great technologies, right? Lots of cool stuff. Quick show of hands. How many people here are software developers that actually write code? Awesome. Great turnout. How many people here just wanted a place to sit? Lost? There we go. All right. You might learn something here, too, as well. All right. So I'm Craig Hurst. I'm the director of Intel's Visual Computing Product Management Group. So I'm responsible for the visual computing products from Intel that are targeted at software developers. So I'm going to spend some time talking about, at a high level, the products we have for visual computing, what they are, how they can benefit you as a developer. And then we've got 3 other sessions following that are going to cover some of the specific tools that we have so you can learn more about those. I'll be around afterwards, as will some of my colleagues. So if you have questions, feel free to follow up afterwards, after the talk today, or even afterwards after the event. So let's jump right into it. So I want to lead off with Intel's vision. This is something that just came out within the last year from Intel. It's a pretty powerful vision statement, right? And I'm just going to read this. This decade, we will create and extend computing technology to connect and enrich the lives of every person on Earth. It sounds pretty bold, and it is bold, and I'm proud to work for a company that has a bold vision like that. But how do I translate that into the work I do? How can I help software developers like you help us reach that vision together? I want to start with a story. So when I first joined Intel, I've been with Intel 17 years. Sounds long when you say it out loud. But when I first started, I remember the recruiter in Arizona. I was going to school in Seattle. It was March. Anybody been in Seattle in March? You know what the weather's like? It's cold, rainy, gray for about 6 months, right? And fly down to Arizona, and the recruiter's up on stage going, "What's that sound?" And everyone's like, "I don't know what that is." So that's the sound of a Pentium being sold. And if you want to join a company that can change the world, join Intel. And that sold me from right that moment. But that sound today is more like 250 core processors being sold. The volume has significantly skyrocketed. So the impact that Intel can make is pretty huge. And when I apply that to the software area for Intel, let's take a look at what we have here for some statistics. Intel is, if we were to be measured as a separate software company, we'd be among the top 5 worldwide. Did anybody here realize that Intel had a huge software presence? Did anybody know that Intel had software tools? All right, thank you, sir. I'll pay you afterwards. But we're directly engaged with over 20,000 developers worldwide. We have a very strong presence, and what we do, we're the Software and Services Group, SSG, that's an acronym that we use. We provide products, developer products like the division I'm in. We provide services, we provide consulting, we help with design. And the focus areas are quite diverse, right? Security, you can read some of these here, visual computing being a part of it. But the real value here is to help developers enhance their innovation, bring exciting new user experiences to life. And the way that we do that is through some of the tools that we create. And so I'm going to talk a bit about those specific tools for visual computing and how with our breadth of our footprint and with developers like you can help unleash those experiences to developers worldwide and help us achieve that vision we have as a company. So a little bit more on our global footprint. At the top of this foil here, you'll see some of the names of companies that are part of the Intel software umbrella. Wind River, McAfee, Havoc. These are companies that are fairly well known in the software space. Worldwide, we have 14,000 plus employees, and we're in over 35 sites worldwide. I haven't been to all of them. I don't have a big enough travel budget to go. My boss is here, so I'm putting in a plug there. I need to go travel some more countries here. But it's a pretty big group that we have. So today, if we look at the 4 big pillars of how Intel is dividing up the developer experiences and the focus areas for software, we have technical and enterprise or HPC computing. Later today, Bethany will be talking a little bit about that. We have highly responsive clients around visual computing. I'll be covering that today as a high level. And then a couple of my colleagues will be covering a few of the other areas around the performance client or high response client areas. HTML5 is a big emerging area of growth that we're focused on. And then embedded systems and devices. And Bethany will touch probably a little bit on that as well. So my area is here. This is the visual computing area. So what are the Intel visual computing tools? What are we all about? Well, it's really about performance optimization, getting the most out of the platform, being responsive, great battery life for a great user experience in a very visually compelling way. And so it's about performance on our graphics parts, first of all. Intel HD graphics is now shipping in every processor that we ship. So graphics comes for free with the CPU. So to take advantage of the CPU means you also need to take advantage of the processor graphics. Responsiveness is a key part to the user experience. How do you make sure you minimize that lag? How do you make sure that if it's a game that you're optimizing, you actually have the best frame rate, you remove the bottlenecks, there's little artifacts, and then battery life. If we look at some of the fixed function elements within our processors, how do we take advantage of those, which are much lower power consuming than a general purpose CPU could be? How do we optimize for power? So these are really the areas that we're focused on for the breadth of Intel's platforms, Ultrabooks, tablets, smartphones. So I'm going to cover a little bit more details on these. So when we first looked at how do we approach the visual computing developer market, what's important to developers who want to deliver these experiences? These are on the left-hand side here, these are kind of the big areas that we wanted to focus on. Performance seemed to be overwhelmingly the #1 area. So we've been focused heavily on performance, and it's really about get the most on Intel, and also get the most on other platforms that you're targeting. Efficiency. I want to write my code and not have to port it to every other processor, every other platform. I want to be as efficient as possible. A lot of software developers more and more are smaller companies, 1- and 2-person operations, and so the more you can be efficient with what you're doing, the more you can make advantages with the resources you have. Innovation. What can we do to help you be more innovative? What can we do to remove some of the barriers to get to that performance, to get to that efficiency, so that you have time available to be more innovative, create interesting features, new user experiences that hadn't been thought of. Future-proofing, that's another big area. So we have some products that have a consistent API that manifests itself across generation to generation of Intel platforms. So if you write to that API, you're guaranteed the next generation processor will work with that API, so you don't have to redo it again. So you're kind of guaranteeing you're going to have some future-proof capabilities moving forward. New OSs, new platforms. That kind of is the general treadmill of the industry, right? Everybody's got to come out with new platforms, new OSs. And so Intel is there at the forefront to make sure that we support the latest OS, we support the latest platform to make sure that you can deliver your applications time to market with when those platforms become available. And then, of course, it's all about making money at the end of the day, right? How do you increase your reach? How can you work with Intel and some of the programs we have to get broader exposure? And so by using our tools and using some of the developer resources as part of Intel's larger developer zone and the developer resources within SSG, we can help you achieve that. So specifically, the tools that we have, so pay attention because there may be a quiz at the end. The tools that we have, the first one here is the Intel Perceptual Computing SDK. This is about adding next generation user interface capabilities to the PC. You may have seen some of this on the show floor in Intel's booth. You may have seen some news come out in the last couple of days. I'll talk a little bit more about that at a high level. Specifically, Barry on my team will be talking about and giving some demos on perceptual computing, so I encourage you to stick around for that. The next one on the list here is the Intel Media SDK. This is really about how to access the hardware video acceleration on Intel's platforms today and get the most out of video performance. So if you're a media enthusiast, you have video products, you're doing video conferencing, whatever it is, this is a product you want to explore. Intel Graphics Performance Analyzers. If you're a game developer and you want to understand where my bottlenecks are, how do I get the best performance for gaming on Intel PCs with processor graphics, this is a great tool for you. The next one on the list here is the Intel SDK for OpenCL applications. Show of hand, how many people here are OpenCL developers in the room? One guy, all right. All right, I'm going to pay you next too. All right, good. So everybody else, I encourage you to check out the OpenCL SDK. I'll cover a little bit on that, and we've got somebody here in the room who can answer any questions if anybody has on OpenCL in more detail. And then the last one is the Intel Performance Primitives library, which is really a library of low-level building blocks performance primitives to help you build faster, better digital imaging media applications primarily. And so that's a library that's available on Intel's website. What I should say is that all of these products, except for the last one, are available for free download. There'll be URLs so you can go to those later or bookmark it so you can find out about them. You can also try out the IPP library as a eval copy if you want to try it out first before you decide if you want to purchase it. But most of these are freely available, so you can take advantage of it right away. So first of all, perceptual computing. As I mentioned, this is really about adding senses to the brain of the PC. We're moving beyond the era of keyboard and mouse. There's a lot you probably have seen here at CES even with gesture recognition. Voice recognition has been around for a while. The technologies are maturing enough now that you can deliver exciting, immersive experiences on PCs with these new enhanced usage models. So with the Perceptual Computing SDK, we're looking at things beyond keyboard and mouse. Gesture, voice, face tracking. I'm going to leave a little bit for Barry so I'm not spoiling everything, but some very exciting stuff. Barry will go through some demos as well to show what can be done, what's the art of the possible. This is available on our website. There's a URL right here for you to check out. The next product, the Intel Media SDK. So again, I mentioned this is about hardware acceleration. So Intel invested significantly in our graphics processors on our CPUs, embedded in the CPU, for fixed function processing of video. So we can do encoding, decoding, pre-processing, all in hardware. It's very exciting because what this allows the platform to do is to have seamless experiences for video playback, video conferencing, encoding, transcoding. Ryan will run through some demos to show the performance capabilities that are seen on Intel's PCs and tablets, but it's pretty remarkable what's happened there. We were very, very quiet about this strategic play that we made, which launched in Intel's second generation core processors. We're now announcing here to show the fourth generation, so we've gone 2 generations since that, and the performance has even gone up even further. The other real benefit besides performance is battery life, and especially on tablets, right? If you're using a fixed function element to do that video decode or a transcoding, you can do that without tapping into the battery as much as you would if it was software only. So it's a free library, APIs available. Ryan will talk more details about that later. All right, GPA, I'm going to cover in a little more detail because we don't have anybody here to cover this tool in particular. So what this is really Intel's graphics performance analyzers. So it's a collection of tools that allows game developers to get the maximum performance and media performance even, right, on their platforms. So the first thing is really something called the system analyzer, which consists of a heads-up display. So you can take a look at your game running in the background with some real-time metrics, in-game analysis, and take a look at, what are my state overrides, what can I do, where are some of my problems. That'll help you kind of triage your game. We also have something for Android developers that are targeting Intel's smartphones, because that's an Android OS on the phone. We have a standalone version of System Analyzer that you can use for CPU graphics, power analysis, so you can understand how can I optimize my game to run best on Intel's phones. We announced this earlier, and it's been very, very popular with a lot of the game developers targeting phones. It's amazing when you look at the usage models for smartphones, how much of the applications are actually games, right? It's a significant portion. I hate to admit I use my phone a lot for gaming, but also social activities and work stuff. But gaming is becoming more and more a major workload for developers to target these devices. Another part of this is frame analyzer, and this gets into a little deeper level analysis, so you can understand down at the draw call level, looking at shaders, textures, direct 3D states, etc. A lot of the details in specific to your game, and to help you identify if I changed how I'm shading something, or if I changed how I'm rendering something here in this pipeline, I can improve my performance and move my frame rate from maybe 15, 20 frames a second up to 30, 40 frames a second. And the last one is something called Platform Analyzer. Platform Analyzer is really looking at the full platform, looking at CPU metrics, looking at graphics metrics for our Media SDK products. So Media SDK is instrumented to support being analyzed in this tool, so you can take a look, is my media application having problems displaying back? Also for OpenCL is supported. If I've written an OpenCL application, I can take a look at some of the problems I may have had with OpenCL. So this is kind of the collection of tools that are available in the graphics performance analyzers. Again, this is available for free on Intel's website. We've had great feedback from developers on this so far. In terms of a little more of the specifics here, the processor support, I'm not going to read this list to you, but there's a lot of support we have for Intel's core processors and Atom processors. Our HD graphics is primarily our target graphics support for this tool. Operating systems, of course, Windows 7, Windows 8, but also Android, as I talked about. We also support OS X, right? If you've got a development system, if you're a Mac developer targeting an Android phone, you can actually use GPA to do the system level analysis, right, to support your needs there. We support DirectX API up to DirectX 11. We support OpenCL, as I mentioned, and also some rich browser support, so we can take a look at some of the workloads that are available in Internet Explorer 9, Google Chrome, Mozilla, Firefox, etc. So basically, GPA, right? If you're primarily a game developer or a heavy graphics developer, this is the tool that should be part of your portfolio. All right, I'm going to jump into OpenCL for a minute here. So let me start off by asking, what is OpenCL? So OpenCL is a standards-based environment for targeting multiple devices on the platform. And you've probably heard a lot of things about GPU, heterogeneous computing. As we're moving forward in the era of computing, it's not about CPU as the only device for programming anymore. The GPU is becoming more and more important to developers and to overall platform-level performance to provide those user experiences. So OpenCL is a standard way you can write your code, one unified code base, to target Intel's CPU, Intel's HD graphics, and you can have your workload run on both the graphics part and on the CPU part. Also, we support Intel Xeon, so if you have a workstation, HPC, enterprise application, our Xeon parts are also supported under Linux, and the newly announced Xeon Phi coprocessor is also supported. So OpenCL was really a standard that's managed largely by Khronos. Intel was a founding member. We are a huge contributor to Khronos. We support that fully, and we've seen that support grow across Intel's product line, and it'll continue to grow. The key usage models here at the bottom for OpenCL is if you're doing image processing, video editing, video playback, gaming, perceptual computing, right? Things that are visual computing in general. Media, etc. Those are really a good usage model for OpenCL because you have the ability to run that across both of our devices. So in terms of the offering specific for OpenCL, I'm mostly talking about visual computing, as I mentioned today at the start of the talk, but because this also supports data center, I wanted to make sure it was clear that we do have Linux support in OpenCL 1.2 spec for those particular customers that are targeting enterprise. But basically, take a look at what CPU you're targeting your applications to run on, look at what operating systems you need to support, and go and check out the OpenCL SDK and download it and play around with it. Okay, IPP. So the Intel Integrated Performance Primitives, that's what IPP stands for. This is a library of highly optimized building blocks for data and media applications. This is something that has been around. Intel has a long heritage, over a decade of optimizations that's happened. We target every generation of processor. The new instruction set that comes out goes all the way back to the early MMX days with SSE, SSE2, AVX, etc. But it's really been optimized for performance, right? How do you get the best performance, and how do you as a developer get the low-level building blocks? So if you want to build your own media codec, if you want to build your own fixed function, you want to build your own filter for an image processing algorithm, how do you do that with very performant algorithms and primitives? This is the library to do that. We've got a lot of customers worldwide that have been using this for years, and we've gotten a lot of good feedback there. It's an evolutionary product that we're continuing to improve. We're expecting to see some significant improvements over the next generation as we release later in the year. but the big areas here are, as I mentioned, performance, future-proofing your code. There are thousands, literally thousands of functions in there. We have huge spreadsheets tracking all the usages, who's using what the functions are, what the performance is on all of those. But for digital media, web, enterprise data, across the board, it's a very broad appeal type of a performance library. And it's really engineered to help you save time, because if you wanted to get that performance on your own and have your own engineering resources focus on, let's say, optimizing an FFT function, you could spend, resources to do that, or you could take something that's already done, drop it in, and know that it's going to be the best you can get, and run with it. So it really is there to help you save time. And by the way, there are a lot of options in terms of how you choose to use this product. There's a lot of licenses for academic, for multi-use, etc. I didn't ask this quick question, show of hands. How many people here are from academia, either students or professors? Anybody? One? All right, great. So we got a little mix of everybody here. So anyway, there are student licenses here as well. And you can, the URL here at the bottom to download a trial version if you want to try it out. Okay, so as I mentioned, these are the 4 pillars for software focus for Intel: technical enterprise computing, highly responsive clients, HTML5, embedded. We're going to have more discussions on the performance client sections, media SDK, perceptual computing, a little more on some of our technical and enterprise computing tools as well. The URLs to download these are here, intel.com/software/VC source. That stands for Visual Computing Source. You can find all the visual computing products there, as well as links to all the other Intel products, intel.com/software/products. And there's a lot of other opportunities or exposure from Intel that you can get if you're interested. These are the sessions that are coming up. We're here until 3 o'clock. We've also got booth demos. Our booth number is listed here. We're also giving away an Ultrabook. Did anybody here know we were giving away an Ultrabook? Nobody got the tweet? Okay, we'll have to fix that. So we are giving away an Ultrabook. There's a URL right here, software.intel.com/CES 2013. Go there, fill out like a 5-question survey, enter your email address, you'll be entered to win. That'll be running over the next couple of weeks, and we'll announce the winner by email. So I encourage all of you to go and give us a little survey, enter to win. We'll be excited about that. And then if you want to follow us and actually get the tweets next time to find out what else we're giving away, here's all of our Twitter handles down at the bottom. Probably the most important one is the VC Dev and then the Intel Dev tools. Those are the top big ones, but also per product. So I've got about 5 minutes, a little less than 5 minutes. I want to open it up for any questions. I've got some motivators for folks if they want to ask questions. I got some giveaways, some T-shirts, and some perceptual computing cameras. Because we love developers, we want to give you the right tools. So let me open it up for questions in the audience. Yes?
You announced OpenCL for Windows on Core i7. Does it also come for Mac and Linux as well, the SDKs?
I'm going to pass it off to Arnon for the OpenCL because he can answer the specifics.
We presented the OpenCL for Core i7, Core i5, and other cores are available on Windows today. The Linux is focused for what we call here the technical enterprise segment, and it's available for Xeon processors and Xeon Phi. For Apple macOS, you should check it out with Apple. They are
because
part of the OpenCL
consortium. Yeah. So macOS, I think Snow Leopard initially had OpenCL libraries. Now, would that work with the latest core processors and the HD graphics, or would basically, are you working with Apple to embed your latest APIs into theirs, so that whenever someone gets the latest SDKs from Apple, it'll automatically work with the Intel processor graphics?
So the way OpenCL works, it's a standard. So every vendor or every SDK that is compliant with the standard, your product will be supported on that.
graphics? I mean, on CPU, yes, but would work
With
on
Apple OS,
Yeah.
yeah, you will need to go and ask Apple. We cannot comment on that.
All
right.
The goal is on Apple platforms that utilize Intel Silicon, they're supporting OpenCL, right? We work with Apple quite closely, but they're responsible for the overall implementation on their platforms. But the goal is absolutely, right, CPU, GPU support, right, for their work they're doing on OpenCL support. All right, question in the front.
I was wondering, what level of hardware do you need to support the facial recognition stuff that you were pointing out? And if you are optimizing for instruction sets that are Intel, like SSE and whatnot, does it give any kind of performance hit to other platforms like AMD or something like that? Is it going to mess it up for those people?
Okay, great question. Here's a shirt. And since you asked about perceptual computing, I'm going to give you one of our cameras as well. So the first part of your question was, what's the level of hardware support needed for facial recognition? So the perceptual computing SDK will support second generation, third generation, fourth generation core processors. So it'll support this generation, the previous generation, and next generation, right? So we're targeting not just what we're coming out with next, but what's also been in the market for 2 years now. So that's really, there probably are some hard limitations in terms of performance needed, but we're not making it a hard requirement there. In terms of the optimization for our libraries on instruction sets, we do support NIPP back through SSE. There are other x86 products in the market that also support that instruction set. We optimize for Intel. We ensure compatibility across other supported architectures.
And as far as the equivalency in graphics, so we're talking HD and integrated graphics, but if you have, say, a laptop that's a bit older and it has some level of discrete graphics and it's not, necessarily that great, is there any kind of a way to test it for the performance, or you just run it and see what happens? I'm just wondering if there's a tool or something to measure what your hardware will be able to do as you get into it before you actually find out the hard way.
So discrete graphics, for discrete graphics that would support OpenCL, for example, you could do that. But are you asking specifically about IPP or?
Well, I mean, like, just for the first question I had about the level of HD 3000, 4000, and the new stuff coming out on Haswell. If you have some other hardware, you have a discrete graphics card, is there a way to just test if it's going to work? If it's up to par. Like I have a laptop with older discrete graphics card that's probably less powerful than the HD 3000. So
Right.
that's probably the low limit is
Right.
the HD 3000.
So for the most part, the discrete graphics parts, we're not really targeting the support for in our products, but we are open to exploring how do we make sure our tools and our analyzers can actually analyze all platforms that are out there in the market. Today, it's been primarily focused on Intel graphics, Intel CPU. Now that we actually have a very strong product in the market for our graphics support, we're looking to expand that, right, and support more usages from developers. So we do some support today, but it's not across the board something that we do. But it's something that we're going to look to grow to.
Okay, thank you.
Yeah. All right, question in the back. So let me see if I'll repeat that and see if I got it. What other device? Oh, you got a Mac.
Yeah, the question was, you've got your own camera, of course, but what other choices can be used to integrate a camera that's going to work with your perceptive systems?
Great. So today, because we just launched in the market at IDF this last year, announced the Perceptual Computing SDK, we partnered with a company, Creative, that's actually building this camera for us, and we brought this to market today. So it has some specific technical requirements with regards to depth recognition, the time of flight technologies, the dual array microphones, the high definition RGB camera. So we had very specific narrow requirements, and we couldn't go broad initially. So we started with something. Our intent is over time, you would expect to see this capability become more and more as a default expectation for platforms. So at some point in time, you could see, and I know that we've talked about this, our senior VP has talked about this just recently, that you will see at some point in time integration of these capabilities into Ultrabooks. So we do want this to become a ubiquitous technology, right, for everybody to experience and benefit from, and not just be one single source. But today it is just one. How do you get one? You asked the right guy. I'll give you one. All right, any other questions? Yes.
I feel like I dream about motions that I could, gestures and motions, but does the developer tool allow me to see how well my gesture will work, how well my movement will be absorbed by the computer? Does it say like, oh, the red light, you can't see my finger, it's too twisted in or something?
Yeah, so great question. One of the biggest challenges that I see for perceptual computing is going to be the overall usability, accuracy. When Barry does his presentation, and I'm eating into a little bit of time here, so I'm gonna cut it off, but he will show you the tools that we have today that show you whether you're detecting your fingers, whether you're detecting certain gesture types, like if I'm doing a gesture of a certain type, does it detect it accurately? But as an industry, I think that overall we need to identify how do we make that usable? How do we make that more accurate? How do we ensure, is there a benchmark even, right? That doesn't exist today. So we're really entering into a new frontier. There are some base level tools there available, but there isn't an overall usability or accuracy tool yet. But I would expect one to come. Absolutely, absolutely, you could. Yeah, so I'm gonna give you a camera and let you try it out. All right, I'm cutting into Ryan's time. I'm sorry, if anybody has any other questions, feel free to grab me afterwards. I will pass it off, and thank you very much for coming today.